Hi, this is just going to be a short little clip about the standard form of a line. So we've talked about what the form looks like when we have it in y-intercept. That would be function notation, f of x equals mx plus b, and m is your slope, and b is your y-intercept. And the other form that you should know is the point slope form, so that's y minus y1 equals m times the quantity x minus x1. M is still the slope, so these m's are exactly the same. The m in this equation and the m in this equation, they're both exactly the same number, and this passes through the point x1, y1. So this is some coordinate. This x1, y1, these is the coordinate that the line is passing through. This x and this y is the same as this x and this y in the slope-intercept form. And so this is point slope form. Okay, so the next one that we wanted to talk about was standard form. And standard form is ax plus by equals c, where a, b, and c are integers. So basically, there's no fractions in standard form. I always like to have my x term be positive as well in standard form. It's not really necessary, but I usually try to make the x positive, the x term. And so notice slope-intercept form is taking the equation of the line, solving it for y. And then standard form is having both the x and the y variables on the left-hand side, and this constant, this c is a constant, on the right. So, and there are some nice things about having a line in standard form. It's easy to pick out the intercepts when you have it in standard form. So let's go over a couple of examples. So this first example will just be taking one that's written in function notation and rewriting it so that it's in standard notation. So if you have function notation, it would be f of x equals 1/2 x minus 2/3. So this is in slope-intercept form. The slope is 1/2, and it's crossing the y-axis at negative 2/3. I want to write this in standard form, which means I want both x and y to be on the same side and a plain old number on the right, and I don't want any fractions. So the first step is to change this f of x to a y, because f of x and y are the same thing. So that would be y equals 1/2 x minus 2/3. And now I want the x and y on the same side, so I'm going to subtract the 1/2 x from both sides. And that gives me negative 1/2 x plus y equals negative 2/3. And we also can't have fractions. I also like x to be positive. So I have two fractions right now, 1/2 and negative 2/3. And I want to multiply by the common denominator of those two fractions so that they're eliminated. So I'm going to multiply everything in this equation by negative 6. So we're going to take negative 1/2 x times negative 6 plus y times negative 6, and that's equal to negative 2/3 times 6. Negative 6, sorry. So negative 1/2 times negative 6 is 3, so that would give me 3x. And then we have y times negative 6, that's minus 6y. And negative 2/3 times 6, remember you can write that as a fraction. 3 goes into itself once and into 6 twice, and so that would be positive 4. And so standard form for this function line written in function notation, which is slope slope-intercept form. In standard form would be this equation, 3x minus 6y equals 4. All right, so one more example. And this time we'll find the equation of the line that passes through the 2 points 5, negative 3, and negative 1, negative 1. The first thing that we need to calculate is the slope. The slope is y2 minus y1 over x2 minus x1. So it would be negative 1 minus negative 3, and then negative 1 minus 5 in the denominator. Subtracting a negative becomes a big plus, so it's negative 1 plus 3, which is 2. And in the denominator, I have negative 1 minus 5, which is negative 6. And so this is a slope of negative 1/3. So now we're going to use the point slope formula. Y minus y1 equals m times the quantity x minus x1. So again, remember that the y1 and the x1 are coming from the coordinate. And you can pick either one of those coordinates. Okay, so again, this y1 and x1 are coming from one of the points. When I'm doing them as examples, I always choose the first one, unless for whatever reason the second one is a ton easier to use. And in this case, both of them are approximately the same, but you can pick either of the points. You could use the negative 1 point if you'd rather. It doesn't matter which one you use. So let's go ahead and plug in these values then. So it's y minus whatever the y-coordinate is, and the y-coordinate is negative 3. And that's equal to the slope, which we calculated earlier was negative 1/3, times the quantity x minus the x-coordinate, which is 5. And now I want to write this in standard form. And I'll also write it in slope-intercept form just so you can see both things. So y minus a negative 3 is the same as y plus 3. And then you can distribute this negative 1/3. Negative 1/3 times x is negative 1/3 x. And negative 1/3 times negative 5 is positive 5/3. Okay, so at this point, this is when I would multiply to get rid of my fractions right here. So if you do it any later than this, then you're going to end up having to add fractions and whole numbers, which is kind of messy. So I find it best to just get rid of the fractions right away, since you know that you need to do that to go to standard notation anyways. So we're going to go this direction to go into y-intercept form, or sorry, slope-intercept form, because we want to do that a little bit differently. And we're going to go down here to go into the standard. Try to write that a little neater. Okay, so what I want to do is multiply by the common denominator. I only have one denominator. Well, there's two denominators, but they're the same number, 3. So we want to multiply everything in this equation by 3. So just don't forget anything. So we're going to have y times 3 plus 3 times 3 equals negative 1/3 x times 3, and then plus 5/3 times 3. So this will be 3y plus 3 times 3 is 9 equals negative 1/3 x times 3 is negative x, and 5/3 times 3 is plus 5. So now we want the x's on one side and the constant on the other, so I'm going to add x to both sides. That gives me x plus 3y plus 9 equals 5, and then subtract the 9. And that gives us x plus 3y equals negative 4. So this would be the standard form. To take this into slope-intercept form or function notation, we want to solve this equation for y, and so there's only one other thing that we would need to do to solve this for y, and that would be, let me just change colors here. So we're going to go into slope-intercept form, and that's to subtract this 3 from both sides. So that would give us y equals negative 1/3 x. And then now you need to do this operation. So we have 5/3 minus 3, and so we need to write that in thirds. And 3 is the same as 9/3, so that would be minus 9/3. And 5/3 minus 9/3 is negative 4/3. So this would be your slope-intercept form, and if you wanted to write this using function notation, it would be f of x equals negative 1/3 x minus 4/3. Okay, and that'll be it for now. If you have any questions about anything, just let me know. Thanks.